Hello, we're about to start. Yeah. Hello, good afternoon. Welcome to our second day of activities for the Research and Innovation Conference here at Monterrey Tech. Today we have two very important people around the world. Professor Linda Newnes, she is located in the University of Bath, and she's the president of the International Society for Transdisciplinary Engineering. And Professor Bryan Moser, he is at the Massachusetts Institute of Technology, and this year he is the president of the conference for Transdisciplinary Engineering to be held on July this time. So welcome. I know that we are almost after lunch according to Monterrey standards. So thank you for delaying your lunch a little bit with us. And let's get started. Just to be different, instead of me presenting our guest for the panel, they will present themselves. That's what they have asked. So Professor Linda Newnes, would you please start and present yourself?
Good, well, I think it's afternoon, everyone. Thank you for having us here. So I'm Linda Newnes, and as Federico said, I'm from the University of Bath. And I just wanted to give you a little bit of background about myself. So I put a normal picture in, so you could actually understand that professors are also human and we're normal. But I would like to say the work I do is on whole life value. And that really means I look at anything from the very concept project stage all the way through to end of life. But what I'm here to talk to you about today is about what we do in transdisciplinary engineering. And I lead a research project called Trend. And this is one of the first of its kind that was supported by our research council in the UK. In effect, they realized that the engineers for tomorrow needed to really design beyond disciplines. So I'll give you a little bit of information what we're doing on there. I won't give you much detail on the other one, but our Centre for People-Led Digitalisation is a £5 million plus project, again from the UK funding bodies and from industry. So it's partially funded by industry as well. And that is an example of a transdisciplinary challenge when you're trying to put digital tools into any kind of business or work. But I will talk to you a little bit about Trend today. And it's literally 2 slides, so not too long. So at Trend, we looked at what was happening in engineering and said you needed to do more than just look at one discipline or just a couple of disciplines. And we wanted industry to be able to understand where they were and where maybe they had strengths and weaknesses in terms of being transdisciplinary and maybe what they'd have to focus on to be better. So one of the key outputs from our research is a transdisciplinary engineering index. And this is effectively an example of what it might look like. So when we're talking about transdisciplinary, we want to go into research, we want to go into companies and say, what are you doing just now? What are your challenges? What are the skill levels of your staff? What kind of tools are you using? What education or training might you need? Et cetera, et cetera. And in effect, we'll be able to go in a bit like, if you do lean manufacturing, you can do a value stream map and you can see where they are now and where they might want to go. And this is what we're trying to do with transdisciplinary engineering, but only when it's appropriate. And I'm just going to stop there because I know there's a lot of questions and answers, and I'm going to pass over to Bryan next.
Yes, thank you. And my apologies for not being able to be with you in person. I hope to visit quite soon. My name is Bryan Moser, and I'm the academic director of a program at MIT called System Design and Management. And as the name suggests, our graduate program and research is in both the School of Engineering and School of Management. And so at this point in my career, even by position, I am inherently transdisciplinary. But my journey started in Kentucky. I'm one of 11 children in a very chaotic, complex family. And my family alone is a strong example of why we need to have a view of dynamic systems and natural systems beyond any single discipline. I went to MIT as a young person for a degree in computer science. I was lucky to work at a lab in Japan, an AI lab for a Nissan Motor company, where I applied all sorts of interesting algorithmic approaches to robotics, some moon systems, and other manufacturing problems. And long before coming back to MIT, I spent 25 years further in industry. I worked for United Technologies on setting up the very first engineering teams that were outside North America, and then later on establishing global engineering teams that had representation from at least 3 continents. This led me to become quite curious about how engineering really unfolds. Not what the Gantt chart says, not what the beautiful paper or organization chart says, but what really happens when teams of teams are working on complex systems. And so I returned to MIT after a doctorate at the University of Tokyo. My research focuses, in fact, on human problem solving when we're faced with complex systems. And by their nature, today's modern complex systems are connected, and no single engineering discipline is sufficient, of course, to create them, to maintain them, to evolve them. Now, we know this is true, but the question is, have our engineering curricula and have our engineering practices caught up to this obvious recognition of the complexity of our modern systems? So we'll talk more about the work that we do, and I look forward to the discussion.
The name of the session is, this is a panel, so we will try to develop a chat, some talk. And for those of you who are online, you could ask your questions through the chat. And for the ones that are here, we have some topics to cover, like in the chat fashion. And then we will have a Q&A session. So the first topic is, in this part of the Atlantic, the word transdisciplinary is not of common use. I understand that Europe is ahead of us in America on this. We have learned about concurrent engineering. We have heard a lot about multidisciplinary work. Actually, in this conference, the word multidisciplinary has been spoken a lot, but very few of transdisciplinary. So how would you define the transdisciplinary approach? This is a question for both of you. Professor Newnes, if you wish.
Right. I will. So one of the things I'm quite careful about, and we spend a lot of time on this, is there is not one single answer to the transdisciplinary approach. But it's unlike it's a mathematical equation and it's right for the all. So we've done quite a bit of research, especially the early stages of our work, where we try to work out what are the key aspects and characteristics we might consider. And what we come up with is you cannot say one thing is an answer. What we have is viewed as a landscape. And in that landscape, you could be at different levels. And in particular, there's a paper we have published on it last year. But if you look at some of the 3 characteristics normally used to describe transdisciplinary, and that would be said is we created this framework where we have these three key characteristics normally used, and we these come back where they are on that. And we find that all helpful. Otherwise, Bryan and I could probably sit for the next 10 hours trying to define what transdisciplinary is, and we'll never get an answer. So we have to be a bit more pragmatic about it and say there's no one single answer. There's a journey you're on, and where are you on that journey? I don't know if you've got anything to add, Bryan, but
I will add another answer, and I'm sure there are multiple answers, but perhaps some are better than others, but I'm not sure mine is. Well, so, of course, we're comfortable with multidisciplinarity. We understand that in solving engineering problems, we must coordinate across the existing state of practice, state of the art, the existing body of knowledge for our professional engineering disciplines. That's a given. Transdisciplinarity implies that even if we coordinate with perfect information, it is still insufficient to solve the real-world problem. Now, one might say it's simply because the existing discipline must evolve. This is true. So perhaps solving a real-world complex socio-technical problem through the act of being multidisciplinary, our single discipline may become something more. I think transdisciplinarity implies something a little bit more profound, which is the act of addressing and paying attention to nature reveals gaps between our disciplines that are not yet treated. And so we must, with curiosity, with humility, while trying to solve these problems in a multidisciplinary way, also be prepared for the emergence of new fields and new disciplines. And the reason that is profound is, especially as engineers, we are often conditioned to be overconfident about our own disciplinary capabilities and reach. And yet what we understand in this complex world, and where nature is an important stakeholder especially, that confidence in our disciplines can often mislead us. So this makes us now think differently about what it means to be an engineer and the set of capabilities and mental frameworks we require to solve the world's most daunting problems.
and that's very challenging, isn't it, Bryan? Because people they can't let go of the lens that they have, and they have to relax a bit and be a bit more inclusive.
It's true. I mean, as an engineer, especially if I'm in the field and I'm working with my colleagues, in fact, my ability to be critical, skeptical, and confident is part of often problem solving. And we often train ourselves to do that based on deep know-how. So now we require this additional mindset, which is perhaps more about curiosity and humility and even an artistic perspective, which may be contrary to our traditional view of engineering.
So just to summarize a little bit of some of the concepts that they have spoken, first, I understand that we have to have a special mindset about to be able to understand that one single discipline is not enough. One simple engineering discipline, if you are an engineer, is not enough. And of course, we are used to work with some other engineer colleagues about several disciplines within engineering. But at this point, probably that might not be enough for some of the complex problems that we have. So that's one, a new kind of mind frame, if you will. And second, we are talking about real problems, real complex problems that society is facing. So we need to interact probably with some non-engineering disciplines at some point. But one of the points that I believe they are very important about what the professors have said is that we have to take into account all the people that will be involved, not only in the solution, but also in the implications of the solution. In management, we call that the stakeholders. So they have to be involved in the development of these tools that maybe at the end will be some mechanical things, some software, some mathematical programming. But if we don't take into account all the stakeholders, something will happen at some point. Thank you very much. So that gives me to the same line. We have existed as humanity for so many years. And we have used engineering lately for so many centuries. We have been comfortable with interdisciplinary and concurrent. So what is the thing that makes now transdisciplinary a new need? And what are the kind of problems that we're facing now that they were not possible to face successfully in the past without this approach?
Linda, maybe
Bryan, I'll let you go first. Yeah.
Sure. Yeah, no, I was thinking, it's a great question because, we absolutely should respect those who came before us and their engineering accomplishments. However, I think we can claim that the complexity is seen by especially the connectivity of the engineered systems we create today has really increased and increased dynamically. So it's happening faster. A simple example, a century ago, if I was teaching at an engineering school and I was teaching about a lighting system and a light bulb, I was teaching about the first automobiles. This is before the telephone network and before the highway system. And so over the last century, what were individual engineering innovations spawned context, both technical context through network and social context through stakeholders that themselves began to become an entity. And then what's happened even more recently? More recently, these previously disparate infrastructures themselves are connecting, right? Our communication system connects to our water infrastructure, connects to our energy system, connects to our telecommunications. And so all of these connections really, and how quickly this is happening, imply, I think, that our traditional disciplines perhaps cannot evolve and keep up as quickly as they might. So this is why we need such humility at this time.
So I would agree in terms of, I would say special education, we're not keeping up. It takes like 2 years to change a degree program at a university sometimes, and by then you're out of date. But what I think what Bryan picks on is a really important point, is in terms of how quick everything's moving. So I do think transdisciplinary was around before. It's not new. We now actually just talk about it. It's been in the education domain since the 1970s and before. So it's not new, and it's been around, I think, without even being branded as transdisciplinary. But I think the speed of change, and for example, the grant we have on digitalization, our focus is on people, not the technology, because the technology is just roaming ahead at speed that we can't keep up with. And the people are struggling in the dynamics and the social systems. So to get some of the benefits, we need to think of the wider aspects. And that's where the transdisciplinarity comes in. I think you mentioned that, Federico, when you said about the people. They're kind of really key. And that's something that as engineers often are quite lacking. They're not that. Bryan's probably slightly an exception because he's management and engineering. Traditional engineers are often quite siloed. So at this point of view, I think it is that speed. And then the awareness as well. So we think we know there's a world shortage of various things. We know there's lack of clean water. We know all these big issues. 30 years ago, it would taken 2 weeks for a letter to get to me to tell me that was the problem. Now I can know within 2 seconds through Facebook, or that's maybe a bit old-fashioned, Instagram or TikTok or whatever's in just now. You can find out what the issue is. And that really changes the dynamics of how we work and what we do and how we have to evolve. I don't know if that answers your question or not.
So now that you're talking about the university and these new generations, the next line I would like to talk is, how could we translate these transdisciplinary concepts to our undergrads and our graduate students so they could start with a fresh start and face these great challenges that we have in the world as time goes by. We thought that COVID was one of the worst things that may happen at this time, but today, or in the last week, we have COVID plus some other Eastern Europe problems on top of it. So what could we do from the educational part, from the universities at programs design, curricula design, to take advantage of this and prepare a little better the next generation? When I was preparing this panel with management here at Tech, I was telling them that being an industrial and systems engineer from my undergraduate and being in operational research in my master's degree and PhD, there are some careers that started with a little bit of this view, like systems engineering, mechanical and management engineering. But now we have the next challenge. So from the universities and curricula design, how could we take advantage of this?
Do you want me to go first, Bryan? So it's like a two-pronged approach to this. And Bryan's used to me saying the words evolution and revolution. So if I look at the evolution point of view, we're already putting transdisciplinary engineering into our curriculum, and we're making it really explicit. However, it is, I would say, evolution at that point, because traditional engineering, because we're in an engineering department. Oh, you heard me okay? Right. I'll repeat a bit. Yeah, sorry. I live in the countryside. Internet is variable. So I should have got Starlink, really. So one of the things I was saying is that we kind of doing two approaches. One is we're creating particular lessons and modules within the current curriculum. And because we have certain criteria in the curriculum, we're embedding it in such a way that it is acceptable to the unit conveners and the course managers. The other aspect we have is we have some places in the UK that are doing transdisciplinary degrees. And then also the mindset of, rather than doing a mechanical engineering degree, why don't we do something like an engineering degree for humanity? Now, what that does, it means it's also forward thinking and doesn't pigeonhole you into any particular discipline. Obviously, engineering is a discipline, but it's quite wide. So that there are two ways you can do it, but we already have modules and activity that we do at both undergraduate and postgraduate level on transdisciplinary engineering. And then we're also looking further afield to particular degrees. But I would probably say we wouldn't brand them transdisciplinary. We would brand them, and it is branding as an extent. They would be put down as, what is the kind of thing that a student would go for that makes sense, that we can also defend as an engineering degree. And one of the things we picked up recently at a digital manufacturing week that we had in the UK at the end of last year, the generation coming up through to education now, they're not necessarily attracted to brands, but they are attracted to what we would call motivations, being good, the environment, causes. So we have to look at degrees that will move with the times, but still have the underlying principles of transdisciplinary in it. That's our kind of approach at the UK at the moment.
Your vision, Professor Moser, and I don't know if you could call about the MIT vision too.
Well, I certainly would never dare to represent MIT by myself, but we certainly believe that disciplinary excellence is still required. I mean, and so the part of this debate is, when should one introduce these additional capabilities? Because we do believe they're additive. This is an additional set of skills that an engineer and non-engineers should have. And we think about three things. One is context, and I think you referred to that previously. The second is comfort with ambiguity. And the third is connectedness to real-world problems. For context, it really is, while solving problems, moving from the solution space, which is where most engineering perhaps has been centered, stepping back to allow the student to be more capable in the design space. Still, I think in project-based learning and other design thinking, this is there, but now also even further to the broader societal problem space. So skills that we teach in understanding stakeholders and interacting with stakeholders and economic analysis and environmental analysis, these are now skills required when framing a problem. Once the problem is framed, I may use multidisciplinary approaches to solve it, but do I have the right problem? Have I framed it in context properly, in partnership, in co-creation with key stakeholders? The second is comfort with ambiguity. And we do, both in undergraduate and in the graduate school, continue to shift our curriculum so that students are rehearsing and ready for real-world industrial teams. When we're involved in a very complex, messy, real-world natural set of issues, that we don't complain that there's not a clean objective function. In fact, our role is to take an ambiguous, complex problem and to reduce ambiguity, to apply creativity, and to find solutions despite all that messiness. And the third I said is connectivity. That is, rather than academics in their ivory tower, we are constantly ourselves as faculty and students involved in solving the problem in the real world, inviting stakeholders to be part of the class, starting companies. 10% of my students start a company while they're still in the program, because it's part of learning and part of delivering must be connected to these real world issues. So context, comfort with ambiguity, and connectivity.
For so many decades. I remember when I was an undergraduate, one of the first things that came into my attention is that almost in every course we have a field project. All the way from Physics 1 and Math 1, they ask us to take the thing that we learn and put it in practice and present the project at the end. So the 55 subjects that I took as an engineer, probably 45 of them involved projects. At that time, they were within our own field, or a little bit with management, being an industrial systems engineer. But now at Monterey Tech, we are not only having individual section projects, but also through the research centers and through the research groups. We are involving students all the way from undergraduate to do so, most in the master's degree, and of course at the PhD level, we're starting to do that. The thing is that we are not calling it transdisciplinarity, and probably we are not in the top percentage of transdisciplinarity at this time, but knowing that, assimilating and put it in practice, I think, is one of the greatest responsibilities that we have as faculty and as university administrations. So,
If I
going
could
on,
comment
Federico.
quickly.
yes, go ahead.
Linda, please.
I was going to re-emphasize what Bryan said about the ambiguity. That is one of the key challenges I think students often face. And sometimes because of the way they're taught, it might be slightly different in the US because you do a lot more problem-based solving, etc. Now in Bath, we do a lot of project work, so we're quite lucky. But some of the students that see, if you gave them the ambiguity, it throws them. But real life is ambiguous. There's not always the right data, not always the right center, not always the right information. And that real life is critical to success, I think.
I was going to comment that Monterey and MIT share a very common background and I think personality in that same sense of having our students being involved in real world endeavors. I think what maybe is different today, because even though we have had this point of view for a very long time, is if I'm collaborating within engineering, there is some common vocabulary. There is some physics and chemistry and other things that guide and structures that provide some ability to translate. But today, I need to have on my development team ethnographers and social scientists, economists, and just local citizens. And this is where the translation between disciplines and across parties is no longer simply based on the math and physics classes we took as undergraduates. So this ability to be performant, not only be performant, but also to be motivated and to be happy while dealing with this much more difficult translation is a big part of what we're trying to teach. And in fact, these tough, wicked problems are even more fun, which is great.
Yeah, and it's exciting. So the students actually, once they get over the nervousness, because they're always worried about their marks eventually, but once they get over that, the actual real challenges, so we work with economists, psychologists, but as Bryan says, the translation, the language, the terminology, the understanding, is challenging but exciting all at the same time. But that's what best engineers or best students do well in these kind of projects. They'll get out and choose any job they like because they're just good.
Yeah, one of the things I get that is so important is to transmit this sense of ambiguity that the world has, as you are mentioning it. And I started as an engineer, as you know, and then I moved to EGADE Business School, so I'm now a part engineer and part management. And most of my projects have both sides. But one of the things that caught my mind when I was starting to teach at the business school is the case method. Also, I used or suffered the case method as a student in my master's, but we're not so used to the case method in engineering, at least into my experience. And one of the things about the case method is that in some of them, you read the whole story, and there are no questions in some of the cases. So you make your own questions, you address what is the main problem, and things like that. And management students are used to that. And engineering school students are not that used to that. So probably that's one of the many gaps that we at the engineering school have to understand a little bit how to transmit this ambiguity into students. Because engineers, tell me what is the resistance of this thing. Tell me what is the frequency. What's the value of X at the end? And you have all the data. And then the first time you go to the field, where is my data? Which data do you want? Which precision? Which instruments? And I always joke with my students and says, when we get into statistics and get this is the data and these are the questions, you are giving 85% of the problem. And you are only going to work in 15. The real thing is to know what you want to do, what is the data, who is it going to affect, and I'm sure that this is the problem. as you mentioned, what is the real problem that we would like to solve, and what are the disciplines? So I believe this transdisciplinarity has some of the answers to all of this. So in the next slide, go ahead.
One of my mentors and colleagues, Professor Don Schoen, you may know one of his books called Frame Reflection. But he had a wonderful phrase that helps me to think about this, which is in design, especially for daunting policy problems. But in design, we can refer to a conversation with the materials. What does that mean? Conversation with materials. It means that nature has a voice and nature pushes back. And so the challenge with traditional engineering education, or even cases, is even if they're partially formed, we need more than that. We need to have a material that pushes back. That's part of the conversation. And so a big part of the active learning movement and project-based learning is to ensure that while addressing ambiguity, that students become very comfortable and capable at having that conversation with the materials, which then allows them to reframe the problem.
Thank you.
Challenge the problem sometimes, isn't it? Because sometimes they get much of the industry we work with, and I'm going to be very careful how I say this, often they think they have a problem, but actually that's not the real problem. When you really start doing the chatting with them, and I am meaning chatting with them, not like hard analysis sometimes, you actually find out what they think their issue is not the issue. It's actually completely different, and what they think they need is definitely not what they need something else. But you actually have to have that conversation, and you need to train students, and some of it is training and comfort and experience and confidence, as Bryan talked about, to actually maybe go back and say, actually, are we addressing the right problem? Is that the real issue? Or are you just dealing what you're seeing as the output of what's happening, not the reality?
And in particular, once we have defined what the real issue is, how are we going to measure that we have done something significantly affecting this thing? It's also the question, right? Because if we're talking about temperature or resistance or pressure, we know what to do. But in a social system, what is the measure of this thing? And after all our endeavors using any kind of mindset, how are we going to measure in a scientific way that we have impacted positively? And that's something that I believe we have to transmit to our students.
Or be careful in using measurement.
I was going to say, I mean, it's one of the challenges we
It's
see.
me who's doing a measure, but you know what I mean.
Well, so one of the challenges we see with I have mid-career students for part of my program. So they've been in the field for 10 years. Very talented engineers. But it is a mental jump to go from optimization thinking to trade space thinking. That is to try to, that once I have a framed objective function, I have some technique to systematically search for an answer and come up with one best way. And so to say that no, in real world problems, it's multidimensional, and there may be a trade space of potentially non-dominated solutions, but they aren't going to be obvious. And we need to change the way we spend our time paying attention off Pareto in order to come up with truly sustainable solutions. And so this jump, it's a big mental jump to go from, optimize to find the best solution to trade space thinking.
And that's, I mean, we've got at Bath, we've introduced a new travel policy, what I was saying, and I sound very insignificant. But what they have then done, because they're looking at a metric, the metric they will use is carbon. But then they say, oh, there's all these other things to consider, but they're not really considering them. What they're doing is that you get pulled into an easy way of measuring. And actually there's well-being, there's caring, there's how happy your staff, there's carbon, there's productivity, there's all these other things that come into it. But you get pulled down to a single metric that's measurable, doesn't look at the trade space, does it? It just looks at an easy out.
totally agree. And that's part of the mindset that we have to change because we are used to single measurements for things, right? And now it's a system that, or a response systemic response that we have to monitor and classify. So in that regard, how is industry at large getting these concepts? And if you could give us some advice on how to influence industry through this.
To be honest, I think industry is probably ahead of academia on this front. But we simply need to look for, well-performing teams in any company or any government organization. There'll be pockets of excellence and maybe brief moments of excellence too over time. And it comes and it goes, as we all know. But there are some common characteristics of high-performing teams under complex problem solving, and I think if anything in industry we can see and can learn. They don't use the words we use. They don't use the labels we use as academics. It doesn't matter, but they do exhibit a spirit of problem solving, the ability to patiently listen across boundaries, but then to also chase diligently options and disciplinary solutions and reducing uncertainty, so that we know the characteristics of a high-performing team. So one thing we saw, I believe, starting in the late 1990s, because so those of us who are old enough remember in the 80s, especially with the Japanese manufacturing techniques, that concurrent engineering and simultaneous engineering became much more popular in the way that both physical locations and teams were organized. We lost that, didn't we? We seem to have lost that in the late 90s and into the 2000s. We became very process-oriented. Everything was about having more standardized value streams with processes and trying to adhere to it, and then we became a dashboard culture. So I think what we've seen is a fair number of companies achieved advantage through semi-automation and process orientation. They achieved early efficiencies, but then stopped learning. And so if I look today at the most performing and innovative companies, they've pulled back from that worldview of how to organize industrial teams. And we're seeing them to be far more flexible, smaller, and more consistent with the sort of concurrent engineering teams that were promoted in the 1990s.
In Europe, in particularly in England, I know that the government is taking a special care of this, besides the universities. Professor Newnes, would you like to tell us a little bit about that?
They are so the word transdisciplinary in research is getting more established. But bear in mind, as part of our portfolio as academics as well, to influence policy and funding, so we do push that as well. In terms of the industrial application, I'd probably be quite aligned with Bryan on this in some aspects, in terms of there is excellent transdisciplinary working happening. They won't call it transdisciplinary. And often those that do call it transdisciplinary are actually not transdisciplinary, if that makes any sense. Because they want to hang on to what they think is the badge, that's a badge of honor, and that's the thing that you want to be. But one thing we did see, and there are pros and cons. I know the pandemic wasn't pleasant, but the thing that showed was agile thinking. It showed.
I think we lost.
Oh, sorry.
We lost you for 15
internet.
seconds, Dr. Newnes.
Again, I keep doing the 15, 20 seconds, don't I? I say one thing we found from the pandemic, and that's not as a negative, it obviously had a lot of negatives, but in working as teams and solving world problems, that's when you saw agility. That's when you saw trust, you saw things. I mean, we even just in the UK, local to us, had transdisciplinary working just to get personal protection equipment to the hospitals. So there were things that went on that if you that drive, and that's probably what I think happens in industry, they do a company alive or solve a problem because there's a issue, whatever, then actually the work is just outstanding. But the other thing that it's not just the engineering, what we saw from the pandemic as the policymakers became agile. So often it's not the engineering causing the problems or the people doing the designing or the experts. Sometimes policy and governance and accreditation and rule ticking. If you look at how quickly we develop vaccines, we still follow protocol as it happened before. It's probably been there for the last 40 years and is no longer relevant. So actually what we became is extremely agile. And the reason I'm comfortable with that is we've done and we work with the medics. And again, back to what Bryan said about language. We were looking at attaching antibodies to cells. And he said, well, we've got to do that for 2 hours. We've got to mix it all up and then we check it. Within 10 minutes, we had 98% effectiveness. But because we challenged it as engineers, so one thing the pandemic is custom and practice and be more agile. And that I thought through the pandemic, we saw amazing transdisciplinary work. Common goal, common needs, challenge, obviously. But that's where engineers and other people, sociologists, everything came to the fold then.
I have a question from the online audience that says, what can we do as an institution, a school, to promote transdisciplinary research if traditional academic metrics make it difficult for researchers to satisfy publication requirements? And more importantly, some researchers are still traditionally hesitant of engaging with academics from less research-oriented schools.
Well, I was in industry for 25 years, and as a researcher, did not publish because that's not why we did research. And I've only been back in academia the last decade or so. So I have some strong opinions on this topic. No, I think, first of all, whether someone's from a traditional research school that's well-funded or not, maybe should not be the issue, although it is a reality. I say to my students, not only at MIT, but I have students at Virginia Tech, I have students in Denver, I have students in Tokyo, that research is a lifestyle. It's a way of seeing the world and being curious about it and investigating. And a good paper, when you submit a good paper that's well framed and hits the mark, it doesn't matter where you're coming from. And for a lot of us who did not join the tenure race when we were 25 or what have you, that getting sufficient publications to earn tenure, it just doesn't matter. It's kind of a joy, to be honest, that I don't have to worry about it. But I think what is important is, if there's a message to university administrators and to academic societies, is I believe strongly we have to really reduce the noise that exists today in publication frequency. We should reduce the number of publications expected and focus more on quality and community. And I think that the outcomes from our work will improve. I don't think it threatens the university model whatsoever to actually have someone produce 3 good journal articles a year as opposed to 10. In fact, I think we'll all be better off. That's a long conversation. I'm happy to have some time.
What do you think, Professor Newnes?
So this is quite a big problem in the UK. So in effect, the UK, I don't know if the US does the same, all their departments get graded in terms of research excellence. So any paper I ever put in to get reviewed, the first line I get back from my colleagues are, I don't really understand this work. Because it's not either mechanical or fluid dynamics or management or whatever. So it does become problematic in terms of your career advancement. However, everything that's been funded is completely the opposite to what we're assessing on papers. So everything is about large grants, interdisciplinary, multidisciplinary, maybe at least multi, inter, then trans. They're really pushing it. But if you're an economist, for example, if you have more than 3 authors on your paper and not in the right type of publication, you'll be unlikely to get an academic position. So what we tend to do, or what I do for career management, is I have to recognize that the staff I manage are from multiple disciplines and multiple domains. So we tend to say, right, if you're an economist, we make sure we also look at your career management. We play that game because we have to play it for their career. Doesn't matter for me, I'm a professor. It's irrelevant to me because another paper makes no difference to what I get. So I do that, and then we do the joint ones that are probably a bit more targeted, and we do both. So I actually think what the world needs, what's been funded, is not aligned with the academic community in terms of papers. But what you have to do is you have to be pragmatic about it. So Bryan and I can have these views because we are where we are. It makes no difference to our career. We're well established. If you're a new academic, Bryan and I would probably be quite different in how we advise you on what to do. We might not agree with the game, but it is a game that we can say we don't want to play, but that's not fair on our younger colleagues. So younger in terms of academic career colleagues, not necessarily age.
I would say this, that most of the breakthrough papers that are disciplinary do have a transdisciplinary mechanism. It's actually what made them breakthrough. But it is still a requirement, especially early in one's career, to be able to participate in that academic society, to understand how your disciplinary community evaluates. And so the faculty I meet, the young faculty at MIT I meet, many of them are jointly appointed. But there's no question that for the discipline where they earn their doctorate, that the paper makes sense. And by the way, Linda, if your colleagues, when they read your paper, only say that it's hard to understand, I've heard much worse. So.
Yeah, see, this is a difference. So I can push back. So I'm at a certain level in an institution that my voice does get heard. But not everyone is like that. So it's quite challenging, I think. But actually, it's the academics are the problem. So it's actually the academics doing the reviewing of their colleagues. And all they're doing is making it circle round and round because they're not understanding the bigger picture.
That reminds me a little bit of a story of an 8-year-old girl who talked to her professor, Dad, and said, Dad, what do you do? I'm a scientist. What does a scientist do? We like to make the world to be better to be lived in. So I believe that at the end of the day, it doesn't matter if you are a professor, a teacher, an industry manager, an entrepreneur. What we like to use is these concepts that we are getting in a teamwork, transdisciplinary, several areas, management, engineering, politics. It doesn't matter. I believe that all of us would like to make this world a little better, probably not for the whole world, for a small segment that we have an influence on. And at the end of the day, that's what everybody wants through their own trenches. So I'm watching at the watch, and time really flies when we are getting fun. So I would like you to ask if you could share a successful story of transdisciplinarity And if it's possible, a second story in which, instead of saying not successful, in which you'll learn a lot from your own experience.
So I unmuted first, Linda. We're in a game show, and whoever hits the button first gets to go. Well, for successful, I think, so many of the global engineering projects that I worked on and continue to consult on are distributed in technical function. They're distributed in terms of the kinds of needs for whom are being solved, and they're distributed in who's providing. So we may have design in 2 countries, detailed design and manufacturing prototyping in a 3rd country, and then production in another. And this is our community. So in those cases, workshop after workshop after workshop, and we know that if let's say an engineering project is a year and a half or 2.5 years at most on average, that there's probably only a few key moments where we can afford to bring everyone together. And when we bring them together in that workshop, for me, the most successful breakthroughs that exhibit transdisciplinarity have been when we have a way to facilitate management, customer, sales, marketing, engineering, manufacturing, operations, support, involved in the design process, involved in co-creation. Awkward for many. I mean, people are busy. They say, this is not my part of the problem, just tell me what to do. And yet we create a culture in which we are helping them to not only build relationships with others on this distributed team of teams, but we're building their mental models, we're building their awareness of where in this real-world complex problem there's uncertainties, pockets of difficulty, key interfaces that may be contrary to their past experience. Finding the criticality of the overall project system. So that's where I've really seen this shine, which is at some point everyone becomes, not only going up to the boundary of their own discipline, but really ready and excited to go beyond the boundaries and to be active listeners and to be engaged in an agile way, as Linda was saying, in finding new hybrid and innovative alternatives that stretch what was common sense before. So that's a good example. For a negative, I've plenty of negative examples where, as I said before, people would just want to stick to their own thing. I was involved in an energy utility turnaround for a few years, and it was a really awful, caustic environment. And the purchasing and engineering and operations in particular. And they had been set up as an operation everyone to just do what's on their inbox, right? Focus on this, and it's not my problem. And it took 4 to 6 months of interaction. And honestly, very bad words said in front of large audiences, screaming, threats, a really tough environment. For good reason. People were not happy. The work they were doing was not meaningful. And as a collective group, they weren't making progress. And so changing, it wasn't just about changing the engineering process to be more collective, but it was really about transforming the entire problem-solving culture of this team of teams. But the first 9 months of this, I would say, was awful and really, really tough. And I learned from that just how important personal fortitude and belief is in solving these more complex problems, because it takes awful lot of social energy to overcome these traditional limitations. I don't know, Linda, do you have any good stories? I think she's frozen.
Yeah, I think a little bit. In the meantime, I have some other questions. One for you, Dr. Moser. It says, I read that your research line is socio-technical systems from your MIT page. How did you get involved from there to transdisciplinarity?
Thanks, that's an interesting question. You're going to make me think. So I'm an engineer by heart, and I'm a computer scientist engineer, but I like to actually build things and solve problems. But then I began to understand that the most interesting problems are societal problems, and that we need to gain the participation, involve people together to solve them. It's in observing and paying attention to what happens when heterogeneous, diverse stakeholders, different groups come to the table. And even if every group does exactly what they're supposed to do, right? They act in what the state of art of their discipline suggests should be true, we can still see great failures. And I became quite curious about that. Probably for me personally, there were some deep intellectual seeds that were planted a long time ago, maybe from my family and my faith, from Sherry Turkle, who was a sociologist who was a mentor of mine, from Don Schoen, who pushed me to want to think a little bit more deeply about why this is the case. And so that in combination with looking for places to publish, someone mentioned earlier, I became part of this particular Transdisciplinary Engineering Society because there were others like Linda and Federico who were willing to listen to my curiosities. So I hope that helps to answer the question.
Thank you. We have another question. I am a student
Am I
from...
back in or not?
Okay, we have
sorry, guys.
Professor Newnes back.
Honestly, Starlink, by Starlink, Linda.
Go ahead, Professor Newnes, we hear you.
Right, so one of the good examples I have is it's a very simple bit of equipment. It was just face shields for personal production equipment. And that's when I saw transdisciplinarity work at its best. And it was done from our department, and it was done through working with the medics, working with doctors, working with nurses, working with supply chain, working with the government. And it just was a dream to watch. But that was because of the people. And the people in terms of they had a common goal, they wanted to help, they were motivated, and they put all as Bryan's discussed, all some of the challenges and different views aside because they had a common goal, save lives. And some of their family were working at the front line in terms of the medics, etc. It just changed the whole mindset, which is amazing to watch. But then the contrary, as Bryan says, when you get people together with different disciplines and they hold the line and they won't change their view and they're siloed and then they debate things, it is draining. And that's not a negative as such, it just takes your time and you feel as though you're getting nowhere, but if you persevere, it comes out at the end. But you have to persevere. And that's a big change management issue and a people issue. It is always necessarily about processes. It is about culture, people, and getting things to work. So I'll stop there in case I lose internet again.
Thank you. We have another question. So Professor Newnes, I understand that the new people-led digitalization center at the University of Bath is a response of the UK to help UK companies to be more competitive through digital technologies. Would you please clarify how transdisciplinary helps you into this endeavor?
So one of the things, and you look at all the reports coming out, the UK is not uptaking digital tools or adopting them as well as many other countries. And they put a call out, and one of the things they put underpinning it was every application had to have the human factor, societal considerations. Because what they recognize and what everything, all the publications are saying is people are core. So in our particular centre, all the other centres are very still technology focused, a bit like Bryan says, oh, I'm going to look at a robot or I'm going to look at something else, but I'll make it about, digital. We actually said, actually, that's not right. What you need to do is really flip this on the head and put the societal culture at the core and look at the people side. So it's transdisciplinary in its nature in terms of, like I say, we have economics, psychologists. So digital tool uptake and adoption isn't just about the tools, it's about the whole context, the awareness, the common goal, and that makes it quite a complex issue. It's all pervasive. It links into everything you do, changes the way you work, changes the way you think about your job, etc. So that's why we believe it's transdisciplinary.
Thank you very much. We have another question. It says, I'm reading that the 2021 International Society for Transdisciplinary Engineering Conference theme was Transdisciplinary Engineering for Resilience Responding to Systems Disruptions. And this year is the future of engineering with three venues: research, education, and practice. Would you please tell us a little bit more about that and what is going to happen in the Congress this summer?
Well, I'll take this. First of all, it's going to be a great event. So Boston is horribly cold in the winter, but wonderful in the summer. So please join us in Boston. You are very welcome. We're lucky at MIT to kind of act as a crossroads. We have such a wonderfully diverse and global presence on campus. And then when we hold events, we have a very usually nice participation. So these events on the campus tend to be highly engaging, just fascinating in terms of who you bump into in the coffee line and so forth. We're focusing on the future of engineering to recognize that, as we said earlier, that although the problems we're solving and their complexity have increased both dynamically in time and in complexity, perhaps our practices, our teaching, and our research have not. And so this is a chance for us to step back and reflect on the latest, well, starting with education. So we'll have several keynotes, a panel, and we have received 143 paper proposals from around the world, from 23 countries. They're likely to be on the order of 100 presented. And about a third of them are about education, engineering education. And so, as an example, one of the keynote speakers is the executive director of a new undergraduate engineering education program called NEET at MIT. And departments at MIT have agreed to permit a cohort of students to select from required classes across their degrees. And they work together in society-facing engineering problems, one on autonomous systems, one on biological systems, another on urban systems. And this small cohort shapes their degree in a very different path than our traditional undergraduates. So this experiment has been going on for a few years, and we'll hear how it's going. We'll also have folks from industry coming in to share with what they're doing to prototype faster, to involve their customers in design, to also be involved in digital twins and digital manufacturing. And finally, there'll be those like Linda and myself who are interested in transdisciplinarity as a research topic. So we do research on engineering. It's a bit meta, not to be confused with that strange company, but very meta of us to try to step back and say, well, what does this say about engineering itself? So that's the community. Again, please attend. I would say the food will be good, but I'm sure it's better in Monterey, but the food will not be bad. I look forward to seeing you there.
Thank you very much. We are almost out of time, so I would like to ask you for final remarks and a final message to our audience. Professor Newnes, if you will.
Hi, so I would just say, I think as whether you're engineer, management, or industrial systems or psychologist, that I think we do have to focus on transdisciplinary. In terms of the challenges that we are facing at societal level, we need to look more than one discipline and go beyond interdisciplinary. In many cases, not all of them. And I think that's what I would recommend, that you kind of widen your horizons and look at the problem-based solving approach.
Thank you very much. Professor Moser, final remarks?
First, I just want to thank Monterey, the community there, for inviting us. Again, we are very sorry we couldn't be there and look forward to being there in person and spending more than a few hours to get to know one another. And you are always quite welcome to come spend time with us in Boston, and I'm sure in Bath as well. I would conclude by saying it is really an exciting time to be an engineer. If we go back 120 years, we didn't have, people were not racing to get tenure in their department. People were out building new systems. We were lifting people out of poverty, finding whole new kinds of education. And maybe this is a time for us to understand that we can have a rebirth in the way that we as society solve problems, but with perhaps more respect for nature, more understanding of dealing with complexity, more humility in the face of our cognitive and other limits. But in the end, being very excited and motivated because it is a great time to be an engineer. So thank you.
Thank you very much. So this is what we have prepared with a lot of love from both continents and both schools along with us at Tecnológico de Monterrey. So thank you very much for being with us this afternoon. And this is it. Thank you.
Thank you very much. Thank you.
Thank you, everyone. Good afternoon.